Hello, this is Mrs. Jimenez, and I'm going to help you with summer school. We're going to work on your functions target, which is actually your last target for 1A. And in that target, you need to work on function word problems. In other words, they're going to give you tables, they're going to give you graphs, they're going to give you equations, and you're going to have to be able to talk about them. Now, as I'm preparing this video for you, you have to remember I don't quite know where you are mathematically, what you remember from your other 1A targets. So I am going to start pretty basic. And after I go through this one problem, then we'll have a conversation. We'll figure out if this was too easy, if this is too hard, and what else I can do to help you. Now, when you go to take the assessment, it's going to look something like this. They're going to give you a graph with information. They're going to give you a tables. And they're also going to give you equations, and you're going to have to be able to talk about what the numbers mean. So I figure the best way that I've always been able to help students is to go ahead and build one together, and then I'll go over the vocabulary, and we'll create a table, we'll create a graph, and we'll even come up with an equation so that you know what you're going to be working on the test. Okay, so our word problems, we always start from the basics. An environmental scientist is studying the growth of redwood trees. She planted a tree that had a height of 5 feet. It grows 3 feet per year. How tall will the tree be after 1 year, 3 years, 5 years? Now, when we're working on word problems, it's important to make sure we understand what's going on in this word problem. So what is this problem about? So we do have a scientist, and what is she doing? She's studying redwood trees. Now, what we need to do is figure out what are the important pieces of information that we need to pull from this. So as I read about this scientist, she planted a tree that had a height of 5 feet. So I'm going to mark that. I don't want to just pull out the 5. I know that the 5 is the height of the tree when she planted it. Then they tell us the number 3. Well, what does 3 mean? It grows 3 feet per year. 3 feet per year. Then we look at the question that they want us to answer. How tall will the tree be after 1 year, 3 years, and 5 years? Now, they want us to find out how tall the tree will be. And then they give us 3 different questions. 1 year, 3 year, 5 years. Now, as a Math 1A student, you are going to have to be able to take a word problem like this and create a table, create a graph, and create an equation. So we're going to go ahead and start pulling some of the important information out. Now, these are the vocabulary words that you'll see on the test, and maybe I need to zoom in a little bit. Okay, so on the test, they are going to ask you things like, what is the initial value? So the initial value, I've given you a little hint here, it's the starting number. So remember, we're talking about a tree. What is the tree's starting number? Remember, it said she planted a tree that had a height of 5 feet. That means our tree was planted. Here's our tree. And it was 5 feet tall when it was planted. So my initial value, that means my starting value, is 5. It's 5 feet. Now, if you want to, you can put feet in there just so you remember what you're talking about. Now, the next thing they want you to do in a function word problem is to figure out what is its rate of change. What is its rate, or how is it changing? So my hint to you is to think about what is happening to the tree. What do we notice is happening? So if we go back into the word problem, what's happening? It's growing 3 feet per year. So I'm going to write that in here, 3 feet per year. So my tree is planted, it is 5 feet tall, and then every year it's going to grow 3 feet. Okay. Now, when you go to write or fill out a table or a graph, you have to actually be able to use these numbers using the words independent value and dependent value. Now, your independent value is your X, and we'll talk about that in a few minutes. But the independent value is the one that we're changing. So like the scientist, what is the scientist changing? Is the scientist changing the feet of the tree, the height of the tree, Or is the scientist changing the years? The scientist is changing the years. That is what the scientist is changing, because she is choosing to go out each year and measure the tree. So she is manipulating the years. That is our independent value. So next we need to have our dependent value. In other words, what is going to be the change? What's changing? What's going to be the total change? Remember, they asked us, how tall will the tree be? So what is going to be the total that we're looking for? We're going to be looking for the change in the height of the tree. So my independent value is years, because that's what I'm changing. And then the dependent value is the height. So when I change the years, the height will also change. Okay, because the height is dependent on the number of years. Now, when you take this information to put into a table, as a mathematician, we always put X here and we put the Y here. The X is on the left, the Y is on the right. Now, what that helps us to figure out is, where does years go? Years is my independent value. It's the one that I'm changing, so I'm going to put years on this side. And then the height is the dependent value, so I'm going to put that on the right side. Now, this is something that you can depend on. Mathematicians do this every single time. X is always on the left, Y is always on the right. So now we can start to compare, if I change the years, what happens to the height. Now, what do we do about numbers in there? Well, we always start with 0. If I have 0 years, so in other words, our scientist has just planted the tree. How tall is the tree when she plants it? Remember, we already pulled that information out. So at 0 years, because the tree is 0 years old in the ground, it is 5 feet tall. Okay. Now, I want you to think, because I know you can do this without having to do the math part of it. If it's been 1 year, how tall will the tree be? So think, it was 5 feet, and every 1 year it grows 3 feet. So after 1 year, how tall will our tree be? It'll be 8 feet tall. Okay, now what about after 3 years? If you want, let's do 2 years first so we can get there. How about after 2 years? So it was 5 feet. After 1 year, it was 8 feet. After a second year, how much will it grow in my second year? It'll grow 3 feet. So now it'll be 11 feet. Notice how I added the 3. So after 3 years, how tall will our tree be after 3 years? Well, each of 3 years, 3 times 3 is 9. So it's grown 9 feet, and it started out at 5 feet. So now it is 14 feet tall. Okay, so what I want you to notice is every time that I added 1 year, I added 3 feet. I added 1 year, I added 3 feet. That is because our rate of change is 3 feet per 1 year. That means for every year, I need to add 3 feet. Okay. Now, that's how we were able to put the information into a table. So now we need to graph it. Now, the important thing you need to know about the graph is they are going to give you a graph, and you're going to have to be able to read the labels and know what's going on. So remember, this is our X and this is our Y. Since this is my X, I'm going to take my label from the X, which is years, and I'm going to write years here. Then, since this is my Y, here is my height. I'm going to put height here. Now I'm going to actually use my numbers. So notice I go 0, 1, 2, 3. I can use those intervals of 0 and then 1, 2, 3, 4, 5. I don't need to write all the numbers. And then I notice here I go from 5 to 8 to 11 to 14. I am going to count by ones also, but I'm not going to write all of my ones. I'm going to say that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's enough to graph what we have. Now remember, since this is 0 years with a height of 5, my coordinate is 0, 5. Okay, again, I'm assuming you remember this from the math, from the past. So if you need help with this, you're going to have to let me know. This is a coordinate of 1, 8. This is 2, 11. And this one is 3, 14. So since this is 0, I go to my 0 on my x, and then I go up to 5. My next point is 1, 8. So I go over to the 1, and then I go up to the 8. 5, 6, 7, 8. And then 2, 11. So I go over to the 2 and up to the 11. So notice how it's making a line. And then over to the 3 and up to 14. There we go. Now, I don't have my ruler, so I am just going to do my best on my line here. Okay, that's supposed to be a straight line. It would be a straight line if I had a ruler. I will get one for next time. Okay, so there's my line. There we go. Make it straight. Okay, now once we've graphed it, this is where they're going to ask you some information. They're going to ask you things like, what is the y-intercept? Now this is our y-intercept, so I'm going to actually label it. This is the y-intercept. And the y-intercept tells us something important. It is the height of the tree when planted. Now, it's important. They're going to ask you, what is the y-intercept? And they're going to ask you, what does that y-intercept mean? And you're going to have to be able to say, it is the height of the tree when it is planted. Then they're going to ask you about its change. So notice that this slant is the slope. Okay, so our slope. Remember, slope is the steepness of the line. Steepness of the line. Now, if you need me to do more on this, on what slope is, just let me know and I can go over more on slope. But what I want you to notice about the slope is that it is the rise over run. Do you remember that? So remember, slope is rise over run. Notice that I'm going up 1, 2, 3. So my slope, remember, I'll write it again, rise over run. I rose 3, and then I run 1. So my slope is 3 over 1. Notice that my y-intercept is 0, 5. That's important because we are going to use those numbers to now write our equation. When you are writing an equation from a function, you need to use this format of y equals mx plus b. Now, I'll give you a little explanation of that too, just in case. This might be a review for you, but I want to make sure we're using all the right vocabulary. Notice that my y, that is my height. Remember, it's my y right here. That is the total height. Slope, m is slope. Okay, m is slope. The x, remember, that was years. We named it years. Remember, x is our years. And b, this is the important one. This is our y-intercept. Okay, it is also our starting value. So if I know what all of the symbols mean, when it's time to write the equation, I can take the numbers that I know and substitute them in. Now, when we write equations in math, we always leave the y as y when we're writing our equation. Of course, the equal sign stays the same. But this time I know the slope. M is slope, and I need to put a number there. So I can go back here and look at what was my slope. Remember, we found it. It was rise over run. So my slope is 3 over 1. As a mathematician, I only want to write the 3, not the 3 over 1. So I'm just going to write 3. Then I have to keep the years in. That's my X, my plus, and then what was my y-intercept? What was the B? It's at the 5. Now, what's really cool about all of this is you see the same numbers in all 3 table, graph, equation. So I want you to take a few minutes, and if you need to, pause, because I do want you to see this connection. I want you to look at the 3 that we used in our equation and the 5 that we used in our equation. And I want you to come back up here to the numbers that we pulled out of the word problem. Do you notice those numbers? Do you notice that our starting value of 5 feet is our y-intercept? Your starting number is always going to be your B. And what do you notice about the rate of change? Remember, it was changing 3 feet per 1 year. Notice in our table, in our graph, it is 3 feet per 1 year. So I could even write that in there. 3 feet per 1 year. And I want you to notice that that's what's down here. 3 feet per 1 year. So if I can pull out the information from my word problems, I can make my table, I can make my graph, and I can make my equation. Now I'm going to have you practice one on your own, and we'll talk about how you can show me your work and what works for you. But then we'll practice a few more of these. Now, if you need to, if this was really easy for you, then just let me know and we can give you some practice problems. If there's things that you don't understand, pull out the vocabulary or the pieces that you need help with, like I need help with the table, or I need help with the graph, or I'd like more help with the equation, and then I can help you with those parts. Okay, see you later.